Hello everyone, welcome back. My name is Jordan Deng. So in today's video, I'm going to discuss how can we use the iron supplement to attenuate the potential cardiopulmonary function impairment during ascent to very high altitude. So this passage that we are going to look at was published in the European Respiratory Journal, and I will just attach a link in the description. If you like, please do check. And this passage was published on 2020, just a really recent passage. And the title of the essay is Iron Bioavailability and cardiopulmonary function during ascent to very high altitudes. Because this topic is very contentious and which attract lots of attention from experts around the world. So the background story of this article is with the increase of altitude when we climb to the mountain Everest or higher mountain, the oxygen concentration within the air decreased. As we all know, this is some general knowledge. And then the hypoxia will occur to our body, will strike our body. And then a condition we termed as a hypoxia pulmonary vasoconstriction will occur. So what is the vasoconstriction? Vessel means the VESSEL means our vessel, of course. Constriction means vessels, the diameter of the vessels gets smaller and smaller, which makes it hard for the air to get into the system. And this hypoxia pulmonary vasoconstriction, the potential mechanism is that the hypoxia inhibit the potassium channels located on the membrane of mitochondria, and then with the proceeding of the influx of calcium, the depolarizations, or I could say hyperdepolarization occurs because the main function of the potassium channels is to fight against the depolarization, causing the polarization. So the vasoconstriction occurs. So what will happen when the HPV occurs? It will lead to the right ventricle afterload increase. So people may ask, what is the right ventricle afterload? The ventricle afterload is used to describe the amount of pressure needed to ejaculate the blood from the heart into the systems. Because the vessel becomes the diameter of the vessels becomes smaller, and then the blood, the resistance of the vessels to the blood increased, which means it takes more work for right ventricle to perform in order to ejaculate the blood out of the heart, and then the right ventricle afterload increased will cause the decrease of stroke volume, and stroke volumes is defined as the amount of blood that pumped out from the heart per contraction cycle. But people may ask, since the BP is higher because of vasoconstriction, why the stroke volume decreased? In fact, the increase of right ventricle afterload will cause the lengthening of our myocardial muscles, which means it will become longer than its optimal length, making it impossible for the myocardial muscle fiber to produce the largest force in the faster velocity. As a consequence, the stroke volume decreased. Since stroke volume decreased, and the individuals still performed exercise in the high altitude, the heart rate have to be increased in order to maintain the cardiac output, because the famous equation cardiac output equals stroke volume times heart rate. As a result, it's impossible for the body to maintain the stroke volume. The exercise capacity or VO2 max decrease. So this is the background story. And what can be done to attenuate the reduction of stroke volume? Must be something to do with to figure some way to prevent the hypoxic pulmonary vasoconstrictions. So the method that this study used is 18 subjects were recruited into the study. One group of them, they were separated into two groups evenly, and then one group as labeled as salient group, which is a control group, and another group was labeled as intervention group, and the intravenous ferric carboxymaltosis were performed. Is this kind of the iron supplement that, if you want to call, mentation, and the things that we measured is stroke volume, cardiac output, heart rate. Let me change the color. Right ventricle systolic pressure, left ventricle indice myocardial performance, and the right ventricle indice myocardial performance. Those indices is used to indicate the performance of the ventricle. The higher the value of the indice, the more impairment will be. And also the periphery oxyhemoglobin saturation, which we termed as SpO2, and also the pulmonary vascular resistance as the HPV. And the result is the left ventricle indice myocardial performance and the right ventricle indice myocardial performance was significantly with the increased altitude, as this is what we expected. And then in the iron group, the degree of impairment in the right ventricle indice myocardial performance was reduced, which means the p-value between the iron group, intervention group, and the control group is smaller than 0.05. And we are 95% confident to say that the intravenous iron could attenuate the impairment of the right ventricle myocardial performance, whereas the p-values in the left ventricle indice myocardial performance is larger than 0.05, which means the iron supplement will not attenuate the impairment of the left ventricle performance. And then in terms of stroke volume, the stroke volume is higher when we had the pulmonary vascular resistance remain similar in both groups. So that we can conclude that the iron bioavailability could attenuate the decrease of stroke volume or potentially increase stroke volume, so that we don't need to increase our heart rate to an unreasonable degree to maintain the cardiac output. And the pulmonary vascular resistance, although it's decreased, it's not statistically significant, which means p-value is still larger than 0.05, but it's smaller than in the iron group. And also, after we performed the correlation test, we found that there was a negative relationship between the stroke volume indices and the pulmonary vascular resistance. So as a result, it indicates the fact that with the increase of right ventricle afterflow, the stroke volume will decrease because because the higher the pulmonary vascular resistance, the more work that the right ventricle have to be done, which means increased right ventricle outflow. As a result, decreased stroke volume indice. Yeah. So let's in the discussion part, as we following those data analysis, they also conclude that the iron bioavailability could increase the oxyhemoglobin saturation, so that the VO2 max or the exercise capacity of the individual in the high altitudes could be maintained. And also, through the right ventricle decrease the right ventricle outflow, we could alleviate the symptom of hypoxia, pulmonary V, and then as a consequence, decrease the PVR, which is the pulmonary vascular resistance. This is what we want to achieve in the background. So yeah, as a result, we can conclude that the iron bioavailability could attenuate the impairment of cardiopulmonary functions during ascent to very high altitude.